This is day 2 of our 4 days of repetitive practice, and I like to call that the rule of 4. You do something briefly 4 days in a row, you're going to learn it, you're going to understand it a whole lot better than if you put that same time frame into just looking at something one day. All right, I'm convinced of that. So let's have at it. Let's get our repetitive practice. I'm still keeping the numbers the same from linear to quadratic to cubic, square root, absolute value. Okay, we're going to work with -2359, and then just like the last lesson set, I'll change these numbers and make some random numbers and let you have a go. You should have a go anyway. You've already seen it yesterday once. See how close you can get to writing something correctly, and I wouldn't expect that to happen yet. But let's see, my camera just seemed to not be so bright. Let's see if I can figure out without my glasses. There we go. Well, let's hope that's okay. All right, so linear function. And everything we're going to do is based on the numbers 0 and 1s. Zeros and 1s. See if you can keep your eyes open for that process. -2, I'm going to say x plus 2. I've created the number 0. I want the number 3. There it is. Magic. I put a 5 in, and I do 5 plus 2 to the first power, which is 7. And 7 plus 3 is not 9. We divide it out of the problem. From 3 to 9 is 6 units of change. Now, if this is the vertex -2, 3, and we can't do this process if it isn't, but patterns emanate from there, and a good math education should have you looking at patterns. Here's a pattern that emerges. Y equals x plus 2 squared, which appears to get us a minimum, a smallest y value. I wonder why. Well, -2 plus 2 squared is 0. 0 squared is 0. Where a positive number squared is a positive. And a negative number squared is also a positive. Those numbers are bigger than that. So there's geometric reasons why we're doing this as well. Okay, remember what a square is. Okay, we're working with shapes here. Kind of lost that in history. We don't see those drawings that much, and we should. So what happens when I drop a 5 in? The numbers change. And I want the numbers to get a 5 to a 9. And I don't care what I multiply by. -2 times anything. -2 plus 2 squared times anything is 0. So it doesn't matter what I put here. That's going to work now. And it's going to be the minimum. But if I put a 5 in, I'm seeing 7 squared. Students have a hard time seeing that at my Algebra 2 and Pre-Cal level, more so than my Algebra 1 students, because my Algebra 1 students get drilled with linear functions and they come in with linear mindsets. All right, I'm on a roll already. How do I get from 3 to 9? 6. And I also think at this stage we should be solving equations. So let's solve an equation here for a random number 100. Well, how do you get from 3 to 100? Got to have 97 units of change. How do you measure this? Well, we measure it from -2, plus minus, and we've got squaring, so we got to have some square rooting. And we got multiplication, so we got to have some division. I'm very big on inverse operations, and let you see how that works. Let's put 6 over 49 times this answer, -2 plus minus the square root of 97 over 6/49. I haven't worked with the quadratic formula in years. 2 squared plus 3. I'm suggesting that's going to get us 100. Let's see if it does. Well, the first thing I notice is -2 plus 2 cancels. They're inverses. And squaring a positive or a negative gets us a positive. And squaring a square root inverses. And multiplication and division inverses. And 97 plus 3, there's 100. So I really stress solving equations with inverse operations. All right, let's go over here to cubics. So slope of 0 at the point of inflection. Well, that's perfect cube. So therefore we have x plus 2 cubed plus 3. And now when I put a 5 in, I get 7 cubed. I don't want 7 cubed, which is 343. 7 times 50 is 350, so 1 less. So 343 cancels out of the problem because I got to go from 3 to 9, 6. Now what if the slope was going up at 10 to 1 here? Well, I don't think I know what that looks like until I do a little bit more work. All right, and then we'll change what it looks like. All I know is I'm going up at 10 to 1 right there. And I know negative 2 3's here, and I know 5 9 is somewhere up here. Which side I'm on, I could tell you, but I'm not gonna, that's not the purpose of this video, but let's find out what the equation is first. So I've got x plus 2 cubed, that's still true, but I also have something going up at 10 to 1 at x plus 2, and I have a value of 3. Now when I put a 5 in, I still have to get rid of that 7 cubed. I still got to get that out of the picture, but what do I add to make this work? I think I'm going to need a little more space. I know I need 6, right? I know I need a 6. Let's shift this over a little bit. All right, but what's getting in the way is this. Well, let's put a 5 in. I'm seeing I'm going up 70. I only want to go up 6, so I get rid of that 70. That means that's negative. This is positive. That means this thing looked something like this. Now, which side 5 9's on over here, I'm not sure yet without doing more work. I'm not going to do that right now. It's in the cubic playlist. But that's that equation. I shouldn't have erased it. So y equals 6 over, I got my coffee, but it's not working yet. I'm still in the midst of cognitive decline. There we go. Square root. I think we can cut to the chase here. Square root of x plus 2. And if the smallest area a square can have, if the smallest area a square can be is 0, then the square root of 0 is 0. These squares can keep getting smaller and smaller until there's nothing happening. Okay, and so I put a 3 here, and I think I'm now getting rid of the square root of 7 and going up 6. And the absolute value, y equals the absolute value of x plus 2 plus 3. So I'm getting rid of the absolute value of 7 and going up 6. I think you're starting to see a pattern, I hope. If not, play the video again. It means your brain needs to see it more. Don't be afraid to do that. Okay, and don't say I'm not good at math, because that may not be true at all. I've had a student who said she wasn't good at math. Shout out. She probably doesn't mind me using her name, but I won't. I don't want to get in any trouble. But she, has worked her way up to BC Calc, and now she's taking linear algebra, and good for her. Okay, and she was quite good at math, actually. So let's look at the exponentials and logs. Okay. This might be a little bit different because I put these up without thinking about the asymptotes here. So let's hope I've got some correct ones. But y equals 0 means we're looking at something like this. And 3 to 9 means it's exponential growth since that's smaller than that. And so how did I get from 0 to 3? Well, I think we're looking at the differentials here because I know that y value is a 3. I think I got to go up 3. I don't think the next time I'm going up 3 because I got to get to 9. I think I'm going up 3 here. I think I'm going up 9 there. I wish I had a different number, but it's going to be not 3, 9, second time. And I want to make a 0 out of negative 2, so I say x plus 2. And I want to make a 1 out of the number 5, so I divide by 7. And now I've got the two easiest numbers to work with, 0 and 1, which is what my entire class is based on. Okay? That's that function. Now what if it was y equals negative 4? Well, I'm not going up 3. All right? From negative 4 to 3, I'm going up 7. I'm getting to 3, but I'm going up 7. And from negative 4 to 9, I think I'm going up 13. That becomes the base of the exponential function. Just pointing that out. That's where you get your base. So in other words, I could write this an infinite number of ways as long as I got a differential on the right and a differential on the left, and I know the time frame, negative 2 to 5, or the change in x, which is 7. As long as I know that change, then I can write these quickly and easily. So how do I get from negative 4 to 3? I go up 7. The next time I don't go up 7, I go up 13. And you can plug these numbers in and see if they work. Now, what's the inverse? The inverse of negative 2, 3, got to do this on the fly, is 3, negative 2. And the inverse of 5 to 9, so I'm going to change this to 0. I'll change that to 0. I think I can get away. No, I can't, because that's a little lower. So let's go back to negative 4, and then I'll think about this more later. All right. I probably could, because that would be, yeah, that's what I, yeah, get my coffee here. Cognitive decline continues. Pictures are very helpful. The old man needs the picture here. And let's stay with, do I want to stay with negative 2, 3? No, I want to do 3, negative 2. So we're going to do the inverse. And I'll show you on a piece of paper a little trick to visualize inverses better. But not right now, because I'm in the midst of this. So how do I get to 3? And how do I get to 9? From negative 4. That's very helpful and important here. I guess I'll write this function down here. Let's put this a little higher. Maybe I can sneak it in there. 3, negative 2, and 5, 9 becomes 9, 5. Woo! Okay, so that I got to get to 9. All right, so here we go. I'm getting there. Finally. So y equals, why don't we start with the y that we know, negative 2. And how do I get to 5? I go up 7. It's a logarithm with an asymptote of negative 4, so I'll make a 0 out of that. And now when I plug in 3, 3 plus 4 is 7, but 7 divided by 7 is 1. And we talked about log 1 a little bit. Let's talk about it again. I'm a big fan of repetition. This is asking the question, b to the what equals 1. We just hit 0 again as a concept. And 0 times 7 is 0, which gets me negative 2, so 3 gets me a negative 2. When I put 9 in, 9 plus 4 is 13 sevenths. If I make that the base, then I have log base b of b, which is asking the question, b to the what equals b. That's a 1. Oh, I don't put, okay, so that's a 1. All right, 1 times 7 is 7, minus 2 is 5. It works for that. So we have this, right? What's the inverse of going up really fast? Going up really slow. Okay, so that's how you do that. Now, trigonometry. We introduced the unit circle without even introducing the definitions of the sine, cosine, and tangent functions. But for our purposes right now, I just want you to realize that circumference is 2 pi r. And if my radius is 1, I can draw triangles in here. Lots of triangles, and that's what trigonometry is about. Trigonometry. Right? And we're really looking at the height. The height divided by 1 is really what the sine function is in this instance. And so I get a maximum at pi over 2, which is 1.57. Whatever this distance is, multiply it by 1.57. 1 radian. I'm saying this because I know students have trouble understanding what a radian is. 1 radian is about 57.3 degrees. A good drawing would be, 1 radian would be about 57.3. You tack on another 1.57, which is 3.14 divided by 2, and it goes further up to this location, which is a maximum of 1, which means that 3 pi over 2 is a minimum of negative 1 on this circle. All right, so what's the equation? I'm at a minimum. So the first thing I want is the number negative 2. Oh, I like years, so I'm going to change this to 1990. All right? And I'll change this to, so we got a population of foxes or something. It goes up, they eat the rabbits, and there are no rabbits, population comes down, so on and so forth. And let's go, I don't know, let's go to 2010. And let's say that we have a maximum, I guess that was 9, huh? I forget what the numbers are, but I can work with this. So what's between 3 and 9? 6. 6 is where we measure from. How do we go up? I don't want, let's make this 10. 11. Let's make it 11. All right, 11 and 3, 14. So we're at height of 7. That's a height of 7. How do I get from 7 to 3? I'm going to actually add 4. Yeah, because I'm working with a minimum. And a minimum means that I'm going to make the number 1990 turn into 3 pi over 2. Yeah, that's fine right there. So I'm going to go x minus 1990. There's magic happening now. 3 pi over 2. Now I do the sine function because I think people have a hard time looking at widths as maximums and minimums on the y-axis, whereas heights on the y-axis seem to match up with heights on the y-axis. So when I put 1990, I'm at 3 pi over 2. I've created the number -1. And what's -1 times 4? -4 plus 7 is 3. So that gives me the height I want. Now, once around the circle is 2 pi, and I come back to where I started from. So that must be 1 revolution. All right, so I want 2 pi, so I guess each one of these is 180 degrees, pi units. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. I want 5 pi to come out of this when I drop in 2010, which is 20 years. This would be really nice to see the period here, because that reduces nicely to pi over 4. Well, I guess we could do that, right? So from here to here is 4 units. From here to here is 4 units. From here to here is 2 units. I've changed by, oh, that's a half a revolution. So this is 8. I told you I haven't had my coffee. So pi is only half of it. So that's 8, and that's 4. 16 and 4, there's your 20 years. Didn't hurt to see that. Sorry for the miscue, but corrected it. And that's half of mathematics, is knowing when you're wrong. And so now I'm going to change, I think I did them all. Tomorrow, I'm going to create 2 more functions off of the exponential and log that are extremely important. And I think after these 2 days of practice, you'll probably be ready to see that. And I think that will have some impact on your future with working with this material. So if you're doing these, pay close attention to the exponential and log tomorrow, because I'm going to present. It's always nice to hear the initial presentations rather than coming in the middle. So if somebody's just looking at this channel and the cubics, so go to the cubic playlist and start looking at it. And if you want more practice doing this in the playlist, I do rapid fire 5. I'll do 5 of the same problem in a row. All right, so let's go change the numbers around now and have at it. What I'll do is I'll change the linear numbers, and while I'm erasing, you try the problem. Give you enough time to pause the video. So here we have a linear function, and let's go through 4, 7. And let's go through, and tomorrow I'm going to do physical context too. Let's do physical context right now for this one, at least for the linear and quad. All right, so 0 gets me about 32, and how about 100 gets me 212. You write the equation of the line that passes through those 2 points, and then use the correct lettering, please. I'll erase. All right. Did you write the following? Did you write y equals x minus 0 plus 32? Did you put 100 in? Get rid of the 100 because 32 to 212 is 180. Did you reduce this and get 9 over 5 times x plus 32? And can you now change the lettering? Yeah. I hope you say Fahrenheit, centigrade. So if you go over to India and you know that it's 40 degrees centigrade, because I was there last year and it was more than that. 40 degrees centigrade, 72 plus 32, 104 degrees. Okay, so what do we use the math for? To study relationships out there in the real world. All right, so now we're doing quadratic. And we'll do also an equation. And I don't know, we'll say, when does this thing hit 50? I don't even know what we've got yet. When does it hit 50? I'll give you one that's canned. And I'll make one up that actually has integer values. So let's start with 4, 7. I like 4, 7. And let's go change of, let's go to 8. Let's go to 10. Let's go to 10. 72. And why don't you go to 79? All right? And then you tell me when that hits a height of 50. Okay? And I'll erase over here. Oh, God, this book is driving me nuts.
Missed the classroom and I missed Renee the cart. All right. So, could you do it in your head? I like to challenge myself, so let's see. So 2, I think we're looking at 2. I think we're looking at 72. Could be way wrong here. Oh, I'm going to 50. Well, I need that. All right, so 7 to 50. I think I'm looking at, ooh, this is harder than I thought in terms of, so that's going to be 43. That's going to be 4 plus or minus the square root of that, I'm sure of. Just give me a second. So that's going to be 36, 72 over 36. All right, that's going to be when it hits a height of 50, I believe. So what do we have? We have y equals x minus 4 squared. Can't be rocket science if I'm doing this, right? So plus 7. Here's my vertex. How do I get from 7 to 79? I got to go up 72 units. What's the square change from 4 to 10? 36. So maybe you're starting to see why I said that. I should have said 2. All right. So let's drop that in and see if we get 50 out, because that's your y value. All right. So what happens to the 4s? The 4s cancel. What happens to squaring this? You get what's inside. What happens to the 2s? They cancel. And what's 43 plus 7? 50. Okay, so it's useful. Now let's do the cubic. All right, with a slope of 0 first. And let's have that be, how about 8, 9 to, cubits, you don't want to get too far, you don't want too big. 12, 17. Okay, because that's an even, so why don't we make that 18? All right, so there we go. So what do we have? We have from 9 to 18, which is a jump of 9. So I don't want that number. How about we make it 6? Well, all right, I'm laboring the point here. From 6 to 18. So first off, let's get the x minus 8 cubed. And I want 6. So that's your point of inflection. And how do I get from 6 to 18? It looks like I go up 12. 8 to 12 cubed. You should know 4 cubed is 64. And then you can fool around with that. Let's change some numbers here. So let's get a cubic that looks like this. All right, let's do a 5, 7. All right, and let's go down at, I don't know, how about 3 to 1? All right, and then we'll just show you that you can do this very quickly and easily. Find the local max, local min, 5 seconds. All right, so here we got x minus 5. Oh, I didn't put it through 2 points. Well, anyway, I've already presented this, so this is that equation. I got to go back and do this again. All right, and we know that that's correct. And so what did I want here? I want one more point. Oh, I can do this. All right, so let's make this thing go through about 11. Do I know 6 cubed off the top of my head? 36 times 6, 180, and 32, 16, I think, right? I think it's 216. So 11, and let's make this above 7. Let's make it 9. Let's make it 9. All right, good enough. So I got to go up 2 units to get to 9 from 7 there. But when I drop 11 in, I get 11 minus 5, which is 6 times 3 minus 18. So I got to add 18 here. All right, notice that's a positive, that's a negative. That's why I get this shape. And when I drop in 11 minus 5, I'll just leave as 6 cubed. That's that equation. Now, how do I get to this location? Might be easier to get to that location. Well, I got to measure from 5. And it turns out it's more than 5. And it comes out to be the opposite of the slope at the point of inflection divided by the 3 times the a term. So this is not a friendly one, but it's 3 times that term, which is 20 over 216. And that would get us this value here. All right. Getting way ahead of myself. Didn't mean to do that, but I got caught up in a conversation. Square root. Okay, I did this one out, and I did this one out already because I figured I'd get into a discussion there, and I did. So hopefully you can just look at those and see the operational division, which we mentioned day 1 on the repetition. Operational division. Okay? Oh, that was the one I did on the beginning of the video. Oh, okay, that's why that's here. Okay. Yeah, I'm in cognitive decline. More coffee. I couldn't even remember doing this. All right, so we got to get 2 new problems here, square root. How about I give you a challenge? 5, 7, let's go in this direction. Let's go to -3. How about we go higher than 7 to 12? No, that's 5. So let's go to 13.
You pause the video, you try that one. I always give that problem as a challenge, and I don't tell anybody how to do it right away. So if you want to not know how to do that and try to get that answer tomorrow, I'll do another one like this tomorrow. But computers didn't used to work with I, so you're not allowed to use negative inside the square root. There's your challenge. Can you come up with that equation without using a negative inside the square root? And I'm going to just give you the answer now. So if you like puzzles, don't listen to this.
Turns out that when you're going in this direction, instead of saying x minus 5, all you got to do is say 5 minus x. And now we're working in the other direction. Got a little reflection here. So that becomes becomes 7. Now you can drop a -3 in. Minus a -3 is 3, so this becomes the square root of 8. And how do you get from 7 to 13? You go up 6.
So you can start playing around with this stuff and get a lot of different ways, different perspectives of looking at things. -2, 3, absolute value, x plus 2 plus 3. Now we're dividing out absolute value change, which in this case is 7 units, because sometimes that's negative. How do you get from 3 to 9? You go up 6. All right, so did I get enough practice in? I hope so. That's that. So tomorrow we'll go through and do this again. And I hope I said what I wanted to say. Not sure I did the quadratic quite the way I wanted to.
So I'm going to be doing a physical context, 0, 3, 267.
And I might as well do this here now, because when I get done with the 4 repetitive days here, I'm going back to the calculus worksheets, and I want to do a 50-question worksheet based on one question. And the one question that people had the most difficulty with coming into my class was writing this equation, because they hadn't had any practice with the zeros and ones. Okay, and so I had to do that for them because they couldn't do it, and that's a shame. That's just too bad. So this is the one I'm going to work with. I've got a ball. It's 3 feet high. I kick it. It goes to a maximum height of 67 feet. It took 2 seconds to do that.
And I'd like to have people know where it is after 4 seconds and when it hits the ground.
And you do that in your head. But without practice and without knowing how, you can't. But I'm telling you, it's easy. But it takes practice. So we'll talk about that tomorrow. All right. Toodaloo, that's a 27-minute video. Longer than I thought it would take, but I'm on a roll here, chatting away, ranting. Ah, God, more coffee.